Yes, good morning, friends. Yes, good morning, friends. How are you? How is your preparations going on? Yes, good morning to you all once again. Yeah, I hope my audio and video is working fine. Okay. Yesterday we have discussed plate tectonics. Okay, today we will see different types of landform. Okay, landforms, different type of landforms. Okay, but anyway, without before going here, I have one. Yes, nature shots. Rajashri, good morning once again. Good morning. Hello. Hi. You see here in Unacademy platform, very important. You have 3-day champions conclave. Okay, it is completely free of cost. It will run from 20 to 22 of this month. Okay, November. Former retired bureaucrats like Amitabh sir, retired IAS, present serving IAS Madam Amanpreet, okay, the recently successful candidate, they all will be there in the panel. Okay, now Dadvivik, good morning, welcome to the session. How are you? Under this conclave, you have different topics, very important topics, like say for example, stepping out of your comfort zone, or should one have a plan B while preparing for UPSC, so on and so forth. In 3 even full insightful days, you will have 15 iconic toppers, 15 top educators, and 15 telling sessions. Okay, so I strongly suggest you kindly block your date and kindly attend the session. It will benefit immensely. Okay, trust me, it will benefit you immensely. You can also ask a lot of your query. Okay, you can use my enroll code, that is SUNEP10. Okay, chalo. You have this stand out facility in the Unacademy platform, where you will get a experienced coach to hand hold you in your entire journey of UPSC preparation. Okay, to clear your doubt, to check your answer script, so on and so forth. You can go for 1 year, 2 year, or 3 year plans. Okay, you will get a discount. You can use my code. The period is from 18 November to 25th of November. SUNEP10. Clear? Chalo. Every Sunday, as you know, that is day after tomorrow, 21st of November, 11 a.m., you have this UPSC compact. In this session, this time it will be history and polity. Okay, 50 questions, 60 minutes, both in English and Hindi. 100 lucky participant will win an Amazon voucher of more than 10,000 rupees. Okay, chala. So, let us begin the session. Clear? See, there are different types of landform. Okay, what is landform? In a very basic statement, or in a very basic form. What is landform? Landform or topography. Okay, landform or topography is nothing but the relief that you see when you go from one place to the other. If you find a mountain, then that is a mountain. If you see a plain area, that is another landform. If you see a plateau, that is another landform. Even under the category of this mountain, there are different types of mountains. Even under a plateau, there are different types of plateau, so on and so forth. Whatever you find over the surface of the earth, that is known a landform in a very basic term. Now, such type of a landform is formed because of many different reasons. Like the landform can be formed because of the running water, which is known as a fluvial landform. It may be because of the glacial action. It may be because of the wind. It may be because of the sea wave and sea current, ocean current. Topography is the study of Earth's relief. Okay, topography is the study of Earth relief. Geography is the study of Earth. Earth's description of the Earth's surface is known as geography. Nature shots, that is okay. See, the basic definition of geography is study of the or description of the Earth's surface, that is geography. Topography is study of the relief feature. Clear? I hope that is clear. Okay, now You see here, landform. Let us first see the landform development because of the running water. For any type of landform, there are two important processes that you need to keep in mind. Two important processes are what? Erosion, and the other is deposition. Erosion, in a sense, whether it is wind, whether it is water, whether it is ocean wave, current, so on and so forth. Because of erosion, certain landform is formed. Even the same agent, say for example, we are considering running water. Running water, because of erosion, there will be certain kind of landform. Similarly, running water itself, when it reaches a very low area, it will start to deposit. Such kind of landform which is formed because of deposition is known as depositional landform. So, two important points or two important agents that you need to know as far as the landform is concerned, that is erosional landform and depositional landform. Let us see the running water acting as a very important agent in the formation of landform. And the landform which will be formed is known as fluvial landform. Now, important point is, in the fluvial process, these are the agents: erosion, transportation and deposition. Very important point that you need to know is, you see here, erosion is maximum, erosion of a running water is maximum when the river carries load according to its transporting capacity. You see here, any river which is flowing, kindly pay attention, very important, kindly follow the pointer. Any river which is flowing has two important aspects. One is known as the capacity of a river. Capacity of a river, that is one. The second important thing is competence. Competence of a river. Okay, of a river. Now, what is this capacity of a river? You see, in order to understand the running water landforms or fluvial landform, it is important to know the capacity and competence of this particular river. Okay, so what is the capacity of a river? The capacity of a river is, see, whenever a river is flowing, it has got certain velocity. Okay, now because of this, and it has got certain kind of channel gradient, the gradient. Okay, the water will not flow in a plain area, it will just sluggish. But whenever you have a gradient, the water will flow under the influence of gravity. Now, during its process of flow of the river, capacity means the total amount, or you can say the total weight of the sediments. Okay, sediments that a river is carrying. Means, say for example, just for the sake of explanation, let me tell you how many kg of sediments, or the amount or the quantity of the sediments that a river can carry is known as the capacity of a river. Clear? Please be very clear. Okay, now these particular sediments when a river is carrying, these sediments will have different sizes. A sediments can be as small as a very tiny object. A sediments can be a little bit bigger in the size of a pebbles. It can even be a bigger size. Okay, so the size of the sediments that a river is carrying consists of different sizes. बहुत प्रकार का size होगा, ठीक है? There will be sizes of different dimension. Now, the maximum size or the heaviest weight of the sediments, or the largest size of the sediments that a river can carry is known as the competence of a river. So kindly try to differentiate between a capacity and competence of a river. Capacity means the weight of, or the total amount of sediments that a river can carry is known as capacity. Competence is within that particular sediments, it is consists of different sizes. The largest size of the sediments that the river can carry is known as the competence. I hope this is clear. If you have any doubt, you can interrupt me at any point of time. Okay? But try to remember true understanding. Then it will be very easy for you to have a proper comprehension of the subject. Clear? Are you able to know the difference between capacity and competence? Yes, anyone? Now, you see here, a river acts or behaves in such a way, the river erodes to the maximum when the river carries the load according to its transporting capacity. Now, say for example, if a river is flowing like this, it has got a specific capacity. If the capacity means competence, endurance is endurance is more of a training session, human endurance and all. Okay, Rahul. Competence is a larger size of a sediments that a river can carry is known as the competence. Clear? Clear, Rahul? You see here, whenever a river is flowing, okay, yes, by the flow of the river itself, because of its hydraulic action, certain kind of erosion can be done. But maximum amount of erosion by the river is done through a sediments that it is carrying. A river, when it is flowing, has got certain sediments in it. Now these sediments acts as a eroding tool. Okay, the sediment is acting as a eroding tool. Yes, the water itself will have certain kind of hydraulic action, but the maximum amount of erosion that the river can do is because of the sediments that it is carrying. That is important to understand. Okay, which means the sediments which is there in the water acting as a eroding tool. So these sediments, while flowing with the river, hits the river floor or the side or the bank and erodes the material. Therefore, the amount of sediments that the river is carrying determine its capacity of erosion. Now, if the sediments that the river is carrying is below the capacity, then the erosion will be less. If the sediments is above the capacity, then also the erosion will be less. A river will have maximum erosive capacity when this river is carrying a is almost the same. It is the amount of the sediments that it is carrying and the velocity. Okay, it is the amount of the sediment and the velocity it is carrying. You see here, as far as the temperature is concerned, it will be more during the chemical weathering. Okay, we have already seen the chemical weathering. So it's the temperature of the river. Okay, the temperature of the river will have its impact on the chemical weathering. But as far as the flow dynamics is concerned, it is more about the velocity and the amount of the sediments that it is carrying. Clear? Anyways, chalo. So, suppose if a river is having more sediments, what will happen? Beyond its capacity, the river capacity, if it is carrying more sediments beyond its capacity, what will do? Deposition will start to happen. Now, if the river is carrying less amount of sediments, its eroding capacity is also reduced. Therefore, maximum erosion of any river will happen when it carries sediments to its transporting capacity. That is the short point you can conclude. Okay. Now, there are different types of fluvial erosion, that is erosion done by the river. One is solution or corrosion, that is dissolution of a soluble material. Whenever a river is flowing over a surface, the nature of the underlying rock or underlying surface is important. If the nature of the underlying rock is soluble in nature, then the river which is flowing, the river has got certain chemicals in it also. So that chemical will react with the underlying rock and dissolve the material in the underlying rock and flows ahead in the form of soluble material, known as solution or corrosion. Very important term, corrosion. C-O-R-R-O-S-I-O-N. Okay. A7, I think that is clear. Do you still have doubt? Regarding the temperature, it may have an impact on the chemical weathering. But as far as the flow dynamics of the river is concerned, it is more of a channel gradient and the amount of sediments that the river is carrying. Okay. Viscosity, don't bring viscosity here now. Okay, we are not discussing the nature of the water itself, but more of a flow dynamics which is relating to the erosive capacity of a river. Clear? Viscosity was important during our discussion of the magma or the lava. Okay, magma or the lava, how far it can go. There, that is the applicability. Okay, that is the application of the viscosity. Okay, regarding the lava, whether it is a basic lava or acidic lava. Clear? Okay, anyway, so solution or corrosion. The second one is abrasion or corrosion. That is, you see here, removal of the loosened material of the valley floor and wall with the help of erosional tool. You see, I just told you when a river is flowing, it is having certain sediments in it, and these sediments acts as an important eroding tool. So say for example, these sediments while moving with the river itself, when it is coming in contact with the river floor or site, it acts as an eroding tool and erodes the matter, thereby bringing more erosion. That kind of process is known as abrasion or corrosion. Difference is only O here, A here. Okay, one was the solution. Whenever the river dissolves the underlying rock and flows, that is known as solution or corrosion. But whenever the sediments acts on the site and valley bed, remove means eroding, that is known as abrasion and corrosion. C-O-R-R-A-S-I-O-N. What is attrition? Attrition is whenever these sediments, yes, when it hits the river floor and the site, it removes the material, but at the same time, because of friction and because of mechanical wear and tear, these sediments itself will undergo reduction in the size. That is known as attrition. I hope that is clear. A-T-T-R-I-D-I-O-N, attrition. Now, number 4 is, I told you, yes, one of the most important aspect of erosion by the river is because of the sediments a river is carrying. Why? Because the sediment is acting as a eroding tool. But the river itself, because of its impact, because of its velocity, have certain kind of erosive capacity. That is known as hydraulic action. Clear? Now, one of the important process about initiation of erosion is, you see here, whenever a rain is coming down, hitting the ground surface, okay, certain kind of impact will be here. Because of that, certain small particles will be dislodged from the surface. Okay, that is the first initial point of erosion. Now, you see here, it is not only a single raindrop which is coming. It is millions and millions of it. So when millions of it converge together, it will form a substantial amount of splash erosion that will take place. Now, this splash erosion will merge together to form a sheet erosion gradually with the flow of time. Now, whenever, even in a plain area, there will be certain area which is a little bit depressed like this. It will be depressed. So such a sheet erosion from this region will try to find a lowest point. Now, when it finds the lowest point, it will form a real erosion. Now, this real erosion, multiple real erosion will merge together to form a gully erosion. And this gully erosion finally will turn into a stream flow. That is how. From splash erosion, it will go to sheet erosion. From sheet erosion, it will come to the reel. From reel to the gully, and gully to the stream flow. That is how a sequential development of the stream will take place. Clear? Now, one important thing about the river is a river regime. Okay, river regime. What is a river regime? Any one of you? River regime. Very, very important concept. Okay, what is a river regime? Any one of you? See, river regime is nothing but the seasonal variation in the volume of a river. You see here. Say for example, the river Ganga. in India. What is the climatic conditions of India? Climatic conditions of India, anyone? The climate or the rainfall pattern of India, anyone? The climate or rainfall pattern of India is what? Anyone? It is monsoonal, right? Monsoon. The climate or the rainfall pattern in India is influenced by the monsoon. Okay, monsoonal climatic condition. Okay, now what is the important characteristics of this monsoon type of climate? Anyone? Very simple, you all know. In monsoon type of climate, we have rainfall in the summer, okay, dry season in the winter. Therefore, a river like Ganga will have maximum amount, means the maximum level of water in the river in the summer season. Whereas in the winter season, it will have minimum. And the same cycle will repeat. In the next year, in the next season, again in the monsoon, in the river Ganga, maximum will happen in the monsoon, in summer, minimum will happen in the winter. Which means one simple point is, in 1 year period, this particular river will have one maximum and one minimum level depending on the rainfall pattern. That is, the rainfall pattern is monsoonal in nature. Therefore, river regime means a seasonal variation in the volume of a water in a river. So, a river like Ganga, which is dependent on a monsoon type of a climate, is having a simple river regime. Simple river regime means in 1 year period, it will have one maximum level of or volume of water and one minimum level of water. In a river Ganga, it is maximum is during the summer season, during monsoon, and the minimum is during the winter season. I hope that is clear. Now, what do you mean by double river regime? Double river regimes are the one where in a 1 year period there will be two maximum level. In two different time periods there will be maximum water volume in the river, and correspondingly there will be two minimum. Such kind of a river regime where you have two maximum level in a 1 year period is known as double river regime. One of the best example of a double river regime river, okay, double regime river is Amazon River. Why? You see here, this is equator, this is Earth, this is equator, okay, this is Tropic of Cancer, this is Tropic of Capricorn. Now you see, what is equinox? Equinox is the one where the sun's ray is directly 90 degrees to the equator. Now, in 1 year time period, the Earth is exactly twice at 90 degree as with respect to the equator. In the summer solstice, the apparent shift of the Earth is 90 degree. During summer solstice, it is over the Tropic of Cancer. In the winter, the sun is in winter solstice 90 degree with the Tropic of Capricorn. But in the equatorial region, in 1 year period, the equatorial region experiences the equinox twice. Whenever the sun insolation is 90 degree over the equatorial region, the equatorial region experiences the maximum amount of rainfall. Therefore, if you go and see the equatorial type of climate, it will have two maximum rainfall season. So corresponding to that, as you know, the Amazon River passes through the equatorial region. Therefore, in a river like Amazon, the maximum level of water it will experience twice in a year. In India, okay, I start the session at 11:30, okay? I start the session at 11:30, okay? So, therefore, double river region, example is Amazon River. Since Amazon River is in the equatorial region and equatorial region receives the rainfall maximum twice in a 1 year period, this river will have double river regime. Is it clear? Regarding the river regime, it is very important. Okay. Now, the third type of river regime, I tell you again, river regime is nothing but the seasonal variation in the volume of the water in the river. Now, the third one is the complex river regime. Complex river regime is the one where a river should be very long and should pass through different climatic conditions. Therefore, say for example, a river like Nile, river like Mississippi. See, river Mississippi is there in the North America. It is flowing for a very long distance from north to south like this. There is a river Nile which is there in the African continent. It flows from south to north towards the Mediterranean Sea for a very longer latitudinal distance. During its journey, if you see from the source region of the Nile or the Mississippi to the mouth of the river, you will find, since this river is very long and it is traveling via the longitudinal for a very long distance, what happens is there are different climatic conditions that is experienced in all of this region. Different climatic conditions in a sense, if this region is having some type of a climate, the other region will experience some different type of a climate. Thereby, the level of water or the volume of water which is flowing in this particular river is very difficult to determine. Clear? That's why such kind of a river is known as complex river regime river, which means it is very difficult to determine the level or the volume of water in this particular river. See, best thing is the India. In India, river like Ganga, it is very simple. That's why it is having a simple river regime. The reason is in the summer maximum volume, in the winter it is minimum. Okay, but a river like Nile and Mississippi, it is very complex. The reason is it is a very long river. It passes over a very long distance, and different region will experience different climatic conditions. Thereby, say for example, in one region it is having a rainy season, the other region will have different type of climatic regions. Thereby, the volume of the water in the river becomes very difficult to recognize. Clear? Now, base level of erosion is another very important point as far as the fluvial landform is concerned. What is the base level? There are two important base level. One is known as the ground base level. Okay, ground base level. Ground base level. Now, base level is if a river is allowed without any disturbances to run its course, then this is a sea level. Okay, it is blocked by me, you are not able to see, but you can just follow this line. Okay, you can just follow this line. Kindly follow the pointer. You can just follow this line. Okay, like this. Okay, this is here. Otherwise you follow here. Okay, I'll draw here. You see here like this. Okay, you see, say for example, this is a sea level. Okay, now a river is flowing like this. The present sea level is known as the ground base level, which means if a river is allowed to flow without any disturbance, then ultimately as the time passes by, this river will erode its course and comes to the level of this sea level. That is known as the ground base level. Okay. On the other hand, there is one another base level, that is temporary base level or local base level. Say for example, in the course of the river, if I have a lake like this, okay, if I have a lake like this, then it interrupts the erosion or the base level of the main river. In a sense, if I have a lake here, the river will first try to erode to this level. After that only it will continue to erode further and coming to this point. Okay, so that is the main difference between temporary base level and the ground base level. Now there are two important factors which changes this particular base level. That is, a base level can be changed because of the change in the sea level, right? Because the base level is nothing but the sea level. So in order to change a base level or the ground base level, it can be done through the change in the sea level. Now this sea level can be changed broadly because of two reasons. One is eostatic change, one is isostatic change. What is eostatic change? Now, the actual change in the volume of water that is stored in the ocean is known as the eostatic change. I'll give you one example. Say for example, the glacier which is, or the ice which is over the land is melted. Say for example, the Himalayan glacier system. If it is melted and goes into the ocean, then the ocean water volume will change. Say for example, you have a cup up to the brim, it is full. Now you have an ice cube. If it melts also, it is not going to overflow. Why? Because the displacement that this immersed part is there will be neutralized. Okay, now, but on the other hand, if the ice or glacier which is there on the land is melted, it is going to increase the volume of the ocean or sea water. Okay, that is one. The other is, during a glaciation period, what happens? The water solidifies or freezes out, thereby changing the volume of water in the ocean or the sea. Such kind of change is known as eostatic change, which means the actual change in the volume of water stored. Other is isostatic change. Isostatic change is one where there won't be any kind of change in the volume of the water stored. But on the other hand, because of the landform movement of the surrounding regions will change the sea level. Kindly follow, I'll give you one example. You see here. Say for example, this is a sea level, okay? This is a sea level. This is my coastal region, okay? Coastal region. Now, say for example, the volume of the water in the ocean remains the same. But say for example, this particular coastal region is uplifted because of tectonic activity. We have already seen what is tectonic activity. We have, in the last class, we have seen the plate tectonics also. Now, say for example, because of XYZ reason, if the coastal region is uplifted like this, what will happen? This particular sea level will come down because this coastal landform has been uplifted. So, change in the sea level. So, whenever there is a change in the sea level because of change in the tectonic activity without the change in the actual volume of the water is known as isostatic change. And by the process of eostatic and isostatic change brings the change in the base level of a river. Clear? That is the basic understanding about the river water and its erosion capacity. Clear? Now, as I have already informed you, there are two types of landform. One is the erosional landform, other is the depositional landform. Let us quickly go and see some of the erosional landform. Now, in erosional landform, usually in the upper course, that is soon after the water divide from the place where the river started to flow. Wait, okay, I have one query from A7. I'm just reading the question. See A7, I'll tell you, see. You will come to know a little bit later, but you see here. When a river is flowing, its dynamic changes every time. Okay, keep this in mind. It is a very dynamic process. Once a river is flowing like this, sometimes it will have its maximum erosive capacity. Okay, it will flow in such a way that it is as per its maximum capacity. But a river while flowing, new tributaries will be coming joining. Okay, now when a tributary is coming and joining, then the volume of the water in the river is again increased. Now when this river is flowing like this, it may come across a region where the erosion from the catchment area is very high. Therefore the level of sediments in the river will be carried. Now even the gradient of a river will change. Thereby the flow of the river itself is very dynamic in nature, but ultimately if we just left the river to perform its activity, it will finally erode to the base level. I can say one statement: all the river in the world, if left undisturbed, all the river in the world is always trying to cut its course to the sea level, to the level of sea level. That's why it is known as the grand base level. A7, is it okay? Is it okay, A7? Is it clear now? See, a flow of the river, a river while it is flowing, it is very dynamic in nature, okay? Okay. Anyway, so the first one is erosional landform. In this erosional landform, see, the first one is the river valley, which will happen on the upper course of the river. There. Now, V-shaped valley like this will be there. So this is a erosional landform of the river. But one and such kind of V-shaped valley you will find in the Himalayan river system, and these are known as the gorges. Okay. Now we know one very important point. During the initial state or during the youthness of the river, a river will develop a V-shaped valley like this. But if it allows to continue, it will finally turn into U-shaped valley, and finally it will turn into a featureless plain like this. Okay. Now, important point is the Himalayan river systems are very young. Very young. Why? Because Himalayan mountain ranges is still rising. Okay. Therefore, such kind of a V-shaped valley you will find. Clear? The second type of landform, that is when you come longitudinally, when you flow from the upper stream towards the middle section, you will find this waterfall. Waterfall is another erosional type of fluvial landform. Now, there are different types of waterfall. The first one is a Cape Rock Fall. Cape Rock Fall is nothing but, say for example, if the orientation of the underlying rock, say for example, underlying rock is oriented horizontally like this, and this upper part is a hard rock, relatively hard rock, as compared to below you have softer rock, relatively softer rock. What will happen when a river is flowing like this? Since the below part is much softer, it will be eroded much faster as compared to the above, because on the upper part it is much resistant rock, harder rock. Therefore, a waterfall like this will result. This part will be eroded much faster as compared to the above. The top part will be eroded. It will be eroded, but it will be eroded gradually. But the rate of erosion of the underlying below rock will be much faster, thereby creation of such a Cape Rock Fall. Example is the Niagara Fall that you will find belongs to this type of a landform. Okay, now you see here, this particular upper part, the hard rock, also will erode backward gradually as the time passes by, but it will be very slow in nature. On the other hand, the softer part will be eroded much faster. That's why it is said that even the Niagara Falls goes or shift backward year after year. Okay. Okay, Aditya, thank you so much. In India, you have this type of a fall in Chota Nagpur Plateau. Okay, chalo. The second type of waterfall is known as vertical barrier fall. Sometimes what happens, the rock itself, just now in the Cape Rock we have seen the orientation of the rock is horizontal like this. This is a hard rock, this was the soft rock. But in vertical barrier fall, what happens? The orientation of the rock is vertical in nature. So whenever a river is flowing, it makes a waterfall in this region. That is vertical barrier fall. The third type of waterfall is fault plane fall. See, in our discussion in the previous classes, we have already seen the different types of fall. Like this is folding, this is one. The other type is because of the tensional force. Say for example, suppose this is a crust. If there is a tensional force acting in both the direction, a crack is developed. Okay, and this will turn into like this. Faulting will result. Okay, so whenever a river comes here, when it makes a fall, it is known as fault plane fall. Clear? Example in India, the Hundra fall on Suparnarekha river comes under this category. The second thing is Dhyaneshwari. Thank you so much. Siva Samudram on the Kaveri river. Okay, Siva Samudram in the Kaveri river. Now, the fourth type of fall is plateau fall. That is, plateau is the upraised land. Upraised land. Plateau means the upraised land. So, whenever a river passes through or flows through this plateau and falls down on the ocean, such kind of fall you will find. Example, Jog fall on the Sharavati river, that is in India. Clear? The Neck Point fall. Neck Point fall is another type of fall. You kindly follow the pointer you see here. There is a term known as river rejuvenation. Okay, river rejuvenation. River rejuvenation is nothing but when a river gets more energy to cut its own course, that is known as river rejuvenation. You see here. Kindly follow the pointer. Say for example, this is my sea level. Okay, so a river is coming and a river is flowing like this. Okay, this dotted line, let this be the sea level, and a river is coming and flowing like this. Say for example, this particular surrounding coastal region is uplifted. It is uplifted. When it is uplifted, what will happen? The sea level will fall down. Now, so whenever the sea level falls down, what will happen? The river will be here. See, in this case, before the upliftment of the coastal landform, the river was very smoothly flowing here. But the moment there is a upliftment of the landform, the sea level will subside, will go down. Therefore, the new sea level is here. Now, in this sea level, you just see this particular river will have to make a waterfall here. Such kind of waterfall, this region, the point from where the river is making a fall is known as a neck point. Therefore, the waterfall is known as neck point fall. Clear? So these are the different types of waterfall. The sixth one is the hanging valley fall. What do you mean by this hanging valley fall? Now, during the glaciation period, during the glacial period, okay, a huge chunk of glacier was here. It was moving in this direction. Now, after the glaciation is over or after the melting of the glacier, a valley will develop like this. So, a river will flow in this direction. Now, there will be a tributary of the river which is coming and joining here. Now, this valley, river valley, looks like it is hanging in the air. That's why such kind of a valley is known as a hanging valley. And the waterfall which is observed in this situation is known as hanging valley waterfall. Clear? Sanjit Gala, thank you so much. Yeah, which one you like me to repeat? Sanjit Kal, which section you want to repeat? Kindly let me know. Yeah, Sanjit Kal, which section you want me to repeat again? Yeah? The neck point? Or which one? I hope you are there. Anyway, we'll end the session here today, okay? We have overshoot the time. I have one answer writing session from 1 p.m. till 2. You see here, I have a Telegram channel by the name of All About geography. Okay, geography. Invite link is t.me/sunep. This is my name and 10. Okay, 10. I upload all my upcoming class schedule in this particular Telegram channel. Also, I share some important PDF files regarding geography or the environment, so you can always come and connect or join with me here in this all about. This is a Telegram channel. Okay, Telegram channel. Okay, I also have answer writing practice session in Unacademy app. You can, it is a completely free of course. It is completely free. You just have to have the Unacademy app. You can come and join me here. I have a session from 1 p.m. every day to 2 p.m. 1 hour session. It is regarding answer writing. We have already finished one portion, the first chapter, that is the answer writing practice of geomorphology. From today, I am beginning the climatology section of answer writing practice. Clear? I also have a plus course. It starts from 7 a.m. in the morning till 9 a.m. in the morning. If you are interested, you can come and join me here. Here in this plus course session, we discuss everything in detail. Why? Because we get enough amount of time. Okay. But in YouTube session, since we don't have enough amount of time, I am not able to explain everything in detail. Okay. Anyway, thank you so much for being such a sporty. Okay, for your patience and cooperation. We will meet again tomorrow at the same time. We will continue with the landforms. Okay, thank you and bye bye.